Notice the coefficients of the variables in the final product of a plus b cubed. These coefficients are the numbers from the third row of Pascal's triangle. The pattern in Pascal's triangle is the sum of the numbers above it. Okay, so for example, we got 2 by doing 1 plus 1 gives us 2. In our next row, we had 1 plus 2 gives us 3, 2 plus 1 gave us 3, 1 plus 3 gives us 4, 3 plus 3 gives us 6, and 3 plus 1 gives us 4, so on and so forth. As you'll notice, the coefficients of a plus b cubed are 1 on our a cubed, 3 on a squared b, 3 on a b squared, and 1 on b cubed. Each row of Pascal's triangle gives us the coefficients of the corresponding binomial expansion. The pattern in the table can be extended to apply to the expansion of any binomial in the form a plus b to the n power, where n is a whole number. Binomial expansion. For binomial expansion in the form of a plus b to the n power, the following statements are true. There are n plus 1 terms, so if we have to the 5th power, we should have 6 terms total. The coefficients are the numbers from the nth row of Pascal's triangle, so if it's n is 3, it would be the third row. The exponent of a is n in the first term, so if we have a plus b to the 4th power, it would be a to the 4th in the first term, and the exponent decreases by 1 in each successive term. The exponent of b is 0 in the first term, and the exponent increases by 1 in each successive term. So if we had a plus b to the 5th power, in the first term we would not see b. In the second term we would have b. The third term would be having b squared, followed by b cubed, so on and so forth, so increasing by 1 in each successive term. The sum of the exponents in any term is n. So if you had n was 5, you could have a cubed and b squared. You could have a and b to the 4th. You could have a squared b cubed. Any combination where the sum of the exponents is the same as your exponent on the outside, your n value. This information is formalized by the binomial theorem, which we will study further when we get to chapter 11. Okay. Starting with number 18, we're going to square this binomial. Okay. So using binomial expansion, we have our Pascal's triangle, so we've got 1, 1, and 1, 2, 1. Okay. That's our first row. That's our second one. Okay, so we've got 2. So that means that our coefficients are going to be 1, 2, 1. So that means that a plus b squared is going to give us a squared plus 2ab plus b squared. Okay, our a value is 3x, and our b value is negative 2. So we're going to plug that in. So we've got a is 3x, and then we have 2 times 3x times b, which is negative 2, plus b squared, so negative 2 squared. Okay, so 3x times 3x would give me 9x squared. 2 times 3 is 6 times negative 2 gives me negative 12. And then we have x. And negative 2 times negative 2 gives me positive 4. Okay, so my final answer is 9x squared minus 12x plus 4. For number 19, we're going to square the binomial. So this term here is a, this term here is b. Okay, so that means that a plus b squared is a squared plus 2ab plus b squared. Okay, so if a is 2j squared, I'm going to plug that in everywhere I should have my a value. My b value is negative 6k, so I'm going to plug that in for b squared. Okay. So 2 times 2 is 4, j times j is j squared. Okay, I've got 2, 2, and negative 6. So that's a total of 2 times 2 is 4, times negative 6 is negative 24. J times k gives me jk. Negative 6k squared is negative 6 times negative 6 is positive 36 k squared. Okay, so my final answer is 4j squared minus 24jk plus 36k squared. Number 20 is asking for the next 2 rows of Pascal's triangle. Remember, to calculate Pascal's triangle, we add the 2 numbers above it. Okay, on the outside we know we have 1s all the way down. Okay, so let's go ahead and put our 1s in. Okay, so this number here is 1 plus 5, which is 6. This number here is 5 plus 10, which is 15. 10 plus 10 would be 20. 10 plus 5 would be 15. 5 plus 1 is 6. Looking at the next row, 1 plus 6 gives me 7. 6 plus 15 gives me 21. 15 plus 20 gives me 35. 20 plus 15 also gives me 35. 15 plus 6 gives me 21. And 6 plus 1 gives me 7. So those would be my next 2 rows of Pascal's triangle. For 21, we're using the binomial theorem to expand the expression. Okay. So we know that we have to have n plus 1 terms. So that means that we have to have 4 plus 1 terms, which is 5. So we should have 5 terms in our answer. The row, we're using the 4th row, okay, of Pascal's triangle, which is 1, 4, 6, 4, 1. Okay, so that means that our a plus b to the 4th power is going to be a to the 4th plus 4 a cubed b plus 6 a squared b squared plus 4 ab cubed plus b to the 4th. Notice that the exponents for a start out with 4, then go to 3, 2, 1, and then 0, which means it's not there at all. We don't see it at all. Anything to the 0 power is 1. Then we have b, starts out at the 0 power, so it does not appear in the first term. In the second term, the exponent is 1. In the third term, the exponent, we have b squared, b cubed, and then b to the 4th. Okay, now we identify x would be our a value, negative 2 would be our b value. Okay, so we plug those in. So for a, we've got x, 4 times x cubed. B is negative 2. We have 6 times x squared and negative 2 squared plus 4 times x times negative 2 cubed plus negative 2 to the 4th power. Okay, so that means that we have x to the 4th minus, because we have 4 times negative 2, negative 8x cubed. And then we have negative 2 squared would be positive 4 times 6 is 24 x squared. Negative 2 cubed would be negative 2 times negative 2, which is positive 4, times negative 2 would be negative 8. Negative 8 times 4 would give us negative 32 x. And negative 2 to the 4th power would be negative 2 times negative 2, which is positive 4, times negative 2, which is negative 8, times negative 2, which is positive 16. Okay, so we have 1, 2, 3, 4, 5 terms, so that's correct. Our final answer is x to the 4th minus 8x cubed plus 24x squared minus 32x plus 16. Number 22, we're going to use the binomial theorem to expand the expression. Okay, so we've got a plus b to the 5th power would be a to the 5th plus 5 a to the 4th b plus 10 a cubed b squared plus 10 a squared b cubed plus 5 a b to the 4th plus b to the 5th. Okay, we've got, this is a and this is b. So I've got x to the 5th plus 5 times x to the 4th times 2 plus 10 x cubed 2 squared plus 10 x squared 2 cubed plus 5 x 2 to the 4th plus 2 to the 5th power. Okay, so working this all out, I have x to the 5th. 5 times 2 gives me 10 x to the 4th. 2 squared is 4, gives me 40 x cubed. 2 cubed is 8 times 10, gives me 80 x squared. 2 to the 4th be 2 times 2 would be 4, times 2 would be 8, times 2 would be 16, times 5 gives me 80 x plus 2 to the 5th power, which is 32. Okay, so my final answer is x to the 5th plus 10x to the 4th plus 40x cubed plus 80x squared plus 80x plus 32. And that completes our examples for classwork 6-2.